Africa has begun to split open, with fractures appearing across different countries and even splitting a man's house in two. Since then, it has become clear that Africa is undergoing a continental rift. Such a rift occurs when a continent is set to break into two or more parts. When this happens, new continents, islands, and oceans are formed, changing the world as we know it. But why is Africa splitting up? What is causing the land to fracture, and what are the implications for Africans and the world at large? Join us as we explore how Africa is splitting into two continents, an event that most people are unaware of. In 2005, images and reports began to emerge of a continental rift in East Africa. A continental rift refers to the process where a continent seems to break apart or separate into two or more parts. This is a normal geological occurrence worldwide. In fact, every continent we see today was formed through rifts and the shifting of tectonic plates. To understand what's happening in Africa, let's dive deeper. To understand the present, you need to look back hundreds of millions of years. At that time, Earth was a singular solid land mass surrounded by one vast body of water. This single continent was called Pangaea, and the ocean was known as Panthalassa. Over millions of years, the Earth's outer crust underwent cycles of heating and cooling, eventually breaking apart into the continents, islands, oceans, and seas we see today. While the Earth may appear stationary, it is actually in a constant state of movement and change. The crust, or lithosphere, which we stand on daily, is composed of about 15 to 20 tectonic plates that are always shifting, either moving apart or pushing toward one another. These plates form the large landmasses of our continents and islands. Picture these plates as fragments of a cracked shell floating atop an incredibly hot molten sea within the Earth's core. The intense heat keeps these plates in motion, a phenomenon known as plate motion or tectonic shift. Have you ever noticed how South America's east coast seems to fit perfectly with Africa's west coast? That's because these landmasses were once connected. The separation of Pangaea into various continents and oceans occurred as the massive landmass split apart. According to NASA's Earth Observatory, the Somalian plate in East Africa is moving eastward away from the older Nubian plate, which is sometimes referred to as the African plate. Interestingly, both the Somalian and Nubian plates are also drifting away from the Arabian plate in the north. These tectonic movements converge in Ethiopia's Afar region, forming a distinctive Y-shaped rift system. As noted by the Geological Society of London, the separation of the Somalian plate from the Nubian plate is also known as the East African Rift, a network of valleys stretching approximately 2,175 miles from the Red Sea to Mozambique. If the Somalian tectonic plate detaches completely from the larger Nubian plate, it will result in the splitting of the world's second-largest continent into two. This would be an exciting phenomenon for geologists and other scientists, as nothing similar has occurred since South America and Africa split into different continents hundreds of millions of years ago. However, such a separation would not happen within our lifetime, as it would take about 5 to 10 million years for a complete division. A clean breakaway of the Somalian plate from the Nubian plate might not be the only outcome. One possible scenario is a partial separation, which could lead to the formation of a new sea between the two landmasses. This new landmass would include Somalia, Eritrea, Djibouti, and the eastern parts of Ethiopia, Kenya, Tanzania, and Mozambique. There is also a possibility that only eastern Tanzania and Mozambique might separate. Countries currently landlocked, such as Ethiopia and Uganda, stand to benefit from this rift, as the emergence of a new ocean and coastline would greatly improve their economies by providing new opportunities for trade and production. According to Ken McDonald, a marine geophysicist and professor emeritus at the University of California, Santa Barbara, the Gulf of Aden and the Red Sea will flood into the Afar region and the East African Rift Valley, eventually forming a new ocean. This transformation would turn part of East Africa into a separate small continent. Although the rift is visually evident, it is not growing fast enough for a complete split anytime soon, as it is currently expanding at a rate of about 1/4 of an inch per year. Ken McDonald further explained that the current rifting is occurring at an incredibly slow pace, roughly equivalent to the rate at which human toenails grow. However, the exact process by which these rifts form remains a topic of debate among geologists and geophysicists. One widely accepted model suggests that increased heat flow from deep within the Earth causes what are known as thermal bulges, visible in areas like central Kenya and the Afar region of north-central Ethiopia. These bulges are easily identifiable on topographic maps as elevated highlands. As they form, they stretch and fracture the Earth's brittle outer crust, creating a series of normal faults. Most geologists and geophysicists agree that these bulges are caused by heat from mantle plumes, regions beneath the Earth's crust where magma is hotter than the surrounding magma. The extra heat from these plumes melts and thins the overlying crust, leading to the expansion and fracturing of the bulges. This process often results in widespread volcanic activity on the Earth's surface. Above the plume, typically the stretching of thermal bulges is preceded by massive volcanic eruptions that spread over vast areas. These eruptions, often referred to as flood basalts, occur along the fractures of the bulges rather than at individual volcanoes, allowing lava to flow across the land like water during a flood. A prominent feature of ongoing rifting in Africa is the formation of rift valleys, lowland regions that emerge when tectonic plates move apart. Rift valleys can occur both on land and beneath the ocean. Underwater, they form through seafloor spreading, a process distinct from the erosion-driven formation of river and glacial valleys. Many rift valleys are associated with triple junctions, where three tectonic plates meet at approximately 120 degrees angles. In such cases, two arms of the junction may split to form an ocean, while the third arm, known as a failed rift or lacustrine rift, becomes a rift valley. The Atlantic Ocean is an example of this, originating from a triple junction in what is now the Gulf of Guinea. While two arms of the junction led to the ocean's formation, the Oku Trough formed in present-day southern Nigeria. Rift valleys are also found underwater, often separating extensive mountain ranges and forming mid-ocean ridges. These ridges result when tectonic plates move apart, allowing magma to rise from the mantle and solidify upon contact with the cold seawater, creating new oceanic crust. For example, in the northern mid-Atlantic ridge, the North American plate and the Eurasian plate are diverging at a rate of about 1 inch per year. Over tens of millions of years, this process has created rift valleys as wide as 9 miles. Similarly, in the Pacific Ocean, the East Pacific Rise forms rift valleys where the Pacific plate diverges from the North American, Cocos, Nazca, and Antarctic plates. Typical of underwater rift valleys, the East Pacific Rise is dotted with hydrothermal vents formed by geological activity beneath the rift valley, releasing superheated water and fluids into the ocean. A rift valley close by and similar to the East African Rift is the Great Rift Valley. The Great Rift Valley is arguably the most well-known rift valley on the planet, stretching from the Middle East in the north to Mozambique in the south. It is known for being geologically active, with volcanoes, hot springs, geysers, and frequent earthquakes. The East African Rift has two main branches, the Western Rift and the Gregory Rift. These two rift valleys are dotted with volcanoes, from Erta Ale in Ethiopia to Mount Kenya in Kenya, which, although now extinct, is a stratovolcano. Other notable volcanoes include Oldo Inyolongai in Tanzania, Mount Kilimanjaro, a dormant stratovolcano, in Tanzania, and Mount Nyiragongo in the Democratic Republic of Congo. The Western Rift, also known as the Albertine Rift or the Lake Albert Rift, contains the East African Great Lakes. It is one of the most biodiverse areas in Africa, featuring snow-capped mountains, savannas, highland forests, and exotic lakes. On the other hand, the Gregory Rift, named after the geologist who first mapped it, stretches from the Red Sea and the Arabian Sea down to Mount Kilimanjaro. One of the most important features of the Gregory Rift is the Afar Triple Junction, where the Horn of Africa meets the Red Sea and the Gulf of Aden in the Arabian Sea. At this junction, the Arabian Plate, Nubian Plate, and Somali Plate are moving away from each other. Notably, the two arms of the Afar Triple Junction continue to widen through seafloor spreading. One arm extends into the Red Sea, while the other extends into the Gulf of Aden. If this rifting continues, the Gregory Rift could become so depressed that the Arabian Sea floods it, creating a new strait and turning the Horn of Africa into a continental island like Madagascar or New Zealand. An interesting feature of the East African Rift is that, despite both the Western and Gregory branches forming through the same processes, they have distinct characteristics. The Gregory Rift exhibits greater volcanic activity, while the Western Rift contains deeper basins with large lakes and significant sediment deposits. One such lake is Lake Tanganyika, the second deepest lake in the world, while another is Lake Malawi, known for basalt eruptions and active crevice formations. Geologists have recently studied the East African rift system to observe how ocean basins form on land, offering a unique opportunity to study an active rift system, unlike other rifts which are either sediment-filled or underwater. Rift valleys often contain lakes, known as rift lakes, which form when fresh water fills the valley. For instance, over 1 billion years ago, a rift developed in the North American plate, forming a triple junction and a deep valley that eventually became Lake Superior, one of the oldest and deepest rift valleys in the world. Another notable rift lake is Lake Baikal, over the Baikal Rift Valley in Siberia. Lake Baikal is the deepest and oldest freshwater lake, with its deepest parts reaching about 5,387 feet. It holds the record for the largest volume of freshwater, containing around 5,700 cubic miles. In contrast, the Dead Sea in the Jordan Rift Valley is not a true rift lake since the underlying rift did not fully form. The Dead Sea Transform is a geologically complex area where tectonic plates interact in various ways. The surface of the Dead Sea lies 1,407 feet below sea level, and its depth extends about 997 feet into the ground. The East African Rift hosts numerous Rift Valley lakes, including Lake Tanganyika, which spans Burundi, the Democratic Republic of Congo, and Tanzania. And Zambia is home to hundreds of endemic species of cichlid fish. Meanwhile, Lake Natron in Tanzania is a shallow, alkali-rich soda lake with a striking red color due to salt-loving bacteria. Another noteworthy lake is Lake Malawi, also known as Lake Nyasa, which is the third deepest freshwater lake globally, located in the southern end of the Western Rift. The basin of the East African Rift Valley is densely populated and has a high prevalence of waterborne diseases, with about 800 to 1,000 fish species, making it the lake with the richest fish diversity in the world. As the rift continues its gradual process of dividing Africa, the region's significance has grown in the eyes of various stakeholders. From geologists to ecologists, and governments, all are closely monitoring developments within the Rift Valley, which has become crucial for understanding the past course of human evolution. Numerous hominid fossils have been discovered there, leading to its nickname, the Cradle of Humanity, and sparking paleoanthropological interest. Scientists are now considering how the rift's evolution may have played a major role in the development of our species. Notable discoveries include Lucy, a hominid skeleton over 3 million years old unearthed in Ethiopia, and Turab Boy, an almost 2 million-year-old hominid skeleton found in Kenya. Many experts believe that the East African Rift's unique structure fostered an environment conducive to life, with the rift's presence potentially making East Africa particularly sensitive to climate change. This shifting climate might have driven our ancestors toward bipedalism and increased brain size as they adapted to these changing conditions. The East African Rift system, with its complex segments, provides insight into how continents divide and oceans form. Yet, beyond its geological significance, the Rift Valley holds potential as a power source due to its active volcanic and tectonic activity. The United Nations Environment Programme is currently developing a geothermal energy initiative aimed at harnessing the Rift Valley's underground heat to generate electricity through steam wells. Estimates suggest that a single well could produce enough power for approximately 5,700 homes. If successful, this project would deliver sustainable energy to millions, many of whom currently lack access to electricity. However, while geothermal energy presents a hopeful prospect, the same volcanic and tectonic activities sometimes lead to challenging conditions for local populations. Rising water levels are among the least of their concerns. Oil discovery around one of the rift's lakes could signify a new phase in Africa's geographic transformation. The Rift Valley region faces severe malnutrition and poverty, and its residents live with the unpredictability of an active rift marked by volcanic and tectonic instability, a stark contrast to the enthusiasm of scientists. Although Africa may not split in our lifetimes, the East African Rift will undoubtedly play a defining role in shaping the future in the coming decades and centuries. Thank you for watching another video of Spacetime Atlas. While you're here, click the video on your screen for more mind-blowing videos.